In Texas, when the authority having jurisdiction, or OJ, discovers a tradesman performing work without the required license or operating license, several consequences can occur. Firstly, the AHJ has the authority to issue a cease and desist order. This order mandates that the tradesman must immediately stop all work. Secondly, the AHJ can impose an administrative penalty. This usually takes the form of a fine levied against the tradesman for operating without the necessary license. Thirdly, in specific instances, working without the license is considered a criminal offense, potentially leading to jail time, fines, or both. These consequences are enforceable through various mechanisms. 1. The AHJ can conduct inspections of work sites to identify tradesmen who are not licensed and issue citations accordingly. 2. The AHJ can investigate complaints received from the public or other tradesmen that allege unlicensed activity. 3. The AHJ can initiate legal action, which may involve filing lawsuits to obtain cease and desist orders and enforce penalties. While a municipal court ticket for operating without a permit may be dismissed if the city fails to appear in court, this is generally not the case with cease and desist orders and administrative penalties issued by the AHJ. These actions are typically pursued by regulatory agencies that possess the authority to enforce licensing requirements. From a tradesman's perspective, working without a license might appear to be a minor infraction with limited repercussions. However, the potential for legal action, substantial fines, and being forced to halt work can have significant financial and professional implications. The provided examples of cease and desist orders issued to air conditioning and electrical contractors in Texas clearly illustrate the consequences of operating without the required license. These orders were issued by the Texas Department of Licensing and Regulation, also known as TDLR, for violations such as failing to obtain a license and working outside the authorized scope of a license. These examples should serve as a reminder of the importance of complying with licensing requirements to avoid potential penalties and legal consequences. When considering electrical work, it is also good to know and understand NEC, or National Electrical Code. The NEC contains many tables of information you would need to know to do electrical work. As an example, conductors must be insulated. Insulation prevents unintended current flow that could cause electric shock, overheating, or fire. The type of insulation must be appropriate for the voltage, temperature, and environmental conditions. NEC Table 310.16 provides ampacity ratings for various conductor sizes and insulation types based on temperature ratings. Always consult the latest version of the NEC and local amendments for the most accurate and up-to-date information. When installing electrical boxes and enclosures, proper sizing is crucial to ensure adequate space for conductors, splices, and devices. NEC Article 314 covers the requirements for box fill calculations, which determine the maximum number of conductors allowed in a box based on its size and the size of the conductors. Overfilling boxes can lead to overheating, insulation damage, and potential fire hazards. Electrical panels must be properly grounded to provide a safe path for fault currents. Grounding ensures that in the event of a fault, the current will flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. NEC Article 250 provides detailed requirements for grounding and bonding electrical systems. The size of the grounding conductor must be appropriate for the size of the service conductors. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits and equipment from overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds a safe level, preventing overheating and potential fire hazards. NEC Article 240 covers the requirements for overcurrent protection. GFCI, or ground fault circuit interrupters, are designed to protect people from electrical shock by detecting ground faults. A ground fault occurs when current flows through an unintended path, such as a person's body. GFCIs quickly interrupt the circuit when a ground fault is detected, preventing serious injury or death. NEC Article 210.8 requires GFCI protection in various locations, including bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, also known as SIs, are designed to protect against arc faults which are dangerous electrical conditions that can cause fires. Arc faults occur where electricity jumps between conductors or to ground, creating heat and potentially igniting nearby materials. SIs detect these arc faults and quickly interrupt the circuit, preventing fires. NEC Article 210.12 requires SI protection in many areas of the home, including bedrooms, living rooms, and dining rooms. Wiring methods refer to the types of cables and raceways used to install electrical circuits. Common wiring methods include non-metallic sheathed cable, also known as an M cable or Romex, electrical metallic tubing, also known as EMT, and rigid metal conduit, also known as RMC. The choice of wiring method depends on the application, environmental conditions, and local codes. NEC Chapter 3 covers the requirements for various wiring methods. Electrical equipment, such as lighting fixtures, receptacles, and appliances, must be properly listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. Listing and labeling indicate that the equipment has been tested and meets safety standards. Using unlisted or unlabeled equipment can pose safety hazards. NEC Article 110.3 covers the requirements for electrical equipment. Voltage drop refers to the reduction in voltage that occurs along an electrical circuit due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC Section 210.19a on an informational note number 4 recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Proper conductor sizing can minimize voltage drop. Electrical work must comply with all applicable codes and standards, including the National Electrical Code, or NEC, and local building codes. These codes provide detailed requirements for electrical installations to ensure safety and prevent hazards. Failure to comply with codes can result in fines, penalties, and potential legal liability. Working with electricity can be dangerous, and it is important to follow safety precautions to prevent electrical shock, burns, and other injuries. Always turn off power before working on electrical circuits. Use insulated tools, and where appropriate, personal protective equipment. If you are not qualified to perform electrical work, hire a licensed electrician. Always use appropriately rated and sized conductors for the intended application. Factors include the ampacity of the circuit, the temperature rating of the terminations, and the ambient temperature. NEC Table 310.16 provides ampacity ratings for conductors under various conditions. Different types of electrical boxes and enclosures are designed for specific applications. Metal boxes provide better protection against physical damage, while non-metallic boxes are suitable for damp or corrosive environments. Ensure that the box is appropriately rated for the environment in which it is installed. Raceways, such as electrical metallic tubing, or IMT, rigid metal conduit, or RMC, and PVC conduit, provide a protective pathway for electrical conductors. The choice of raceway depends on the application, environmental conditions, and local codes. Secure raceways properly to prevent damage and ensure compliance with NEC requirements. Terminations are the points where conductors are connected to devices or equipment. Proper termination techniques are essential to ensure reliable electrical connections and prevent overheating. Use appropriate connectors and tools for the type and size of conductor being terminated. Labeling electrical panels and circuits is essential for safety and maintenance. Clearly label each circuit breaker or fuse with the corresponding load or area that it serves. This makes it easier to identify and troubleshoot electrical problems. Maintain accurate panel schedules and update them as needed. Use wire connectors, such as wire nuts or terminal blocks, to splice conductors together. Ensure that the connectors are appropriately sized for the number and size of conductors being spliced. Follow the manufacturer's instructions for proper installation. Provide adequate support for cables and raceways to prevent strain on connections and equipment. Use cable ties, straps, or hangers to secure cables and raceways at appropriate intervals. Follow NEC requirements for support spacing. Sealing conduit systems helps to prevent moisture, dust, and other contaminants from entering the system. Use appropriate sealing fittings and compounds to seal conduit connections and prevent corrosion. Protecting cables and raceways from physical damage is essential to maintain the integrity of the electrical system. Use conduit guards or other protective measures to shield cables and raceways from impact, abrasion, or other potential hazards. Ensure that all electrical work is properly inspected and approved by a qualified electrical inspector. Schedule inspections at appropriate stages of the project to ensure compliance with codes and standards. Address any deficiencies or violations promptly. Grounding electrodes provide a connection to the earth, which helps to stabilize voltage and provide a path for fault currents. Common grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes. The size and type of grounding electrode must comply with NEC requirements. Bonding is the process of connecting metal parts of the electrical system together to create a low impedance path for fault currents. Bonding helps to prevent electrical shock and ensures that overcurrent protection devices will operate properly in the event of a fault. Use appropriate bonding jumpers and connectors to bond metal enclosures, raceways, and equipment. Surge protection devices, also known as SPD, protect electrical equipment from voltage surges caused by lightning, utility switching, or other sources. SPD divert excess voltage to ground, preventing damage to sensitive electronic equipment. Install SPD at the service entrance and at branch circuits to provide comprehensive surge protection. Transformers are used to step up or step down voltage levels to match the requirements of different equipment and circuits. Transformers must be properly sized and installed to ensure safe and efficient operation. Follow NEC requirements for transformer installation, including overcurrent protection, grounding, and ventilation. Control panels are used to house electrical controls, such as switches, relays, and timers. Control panels must be properly designed and constructed to ensure safe and reliable operation. Follow NEC requirements for control panel installation, including wiring methods, overcurrent protection, and grounding. Generators are used to provide backup power during power outages. Generators must be properly installed and connected to the electrical system to prevent backfeeding and other hazards. Follow NEC requirements for generator installation, including transfer switches, overcurrent protection, and grounding. Motors are used to power a wide variety of equipment, from pumps and fans to compressors and conveyors. Motors must be properly sized and protected to prevent overheating and damage. Follow NEC requirements for motor installation, including overcurrent protection, disconnecting means, and grounding. The NEC contains specific requirements for wiring in hazardous locations, such as areas where flammable gases, vapors, or dusts are present. Use equipment and wiring methods that are specifically designed and rated for hazardous locations. Follow NEC Article 500 and related articles for detailed requirements. Renewable energy systems, such as solar photovoltaic, also known as PV, and wind power systems, are becoming increasingly common. These systems must be properly designed and installed to ensure safe and reliable operation. Follow NEC Article 690 and related articles for detailed requirements. Ensure that all electrical work is performed by qualified and licensed electricians who have the knowledge and experience to perform the work safely and in compliance with codes and standards. Verify the electrician's credentials and references before hiring them. When selecting electrical equipment, consider factors such as energy efficiency, reliability, and ease of maintenance. Choose equipment that meets or exceeds industry standards for performance and safety. Regularly inspect and maintain electrical systems to identify and correct potential problems before they cause failures or hazards. Perform routine tasks such as tightening connections, replacing worn parts, and testing safety devices. Keep accurate records of all electrical work, including permits, inspections, and maintenance activities. This documentation can be helpful for troubleshooting problems and demonstrating compliance with codes and standards. Stay informed about changes to electrical codes and standards by attending training courses, reading industry publications, and consulting with experts. Keeping up to date with the latest requirements is essential for ensuring safety and compliance. Understanding the electrical system in your home or business can help you to identify potential problems and take steps to prevent electrical hazards. Learn about the location of electrical panels, the function of circuit breakers, and the proper use of extension cords and power strips. Educate family members or employees about electrical safety and emergency procedures. Make sure everyone knows how to turn off power in an emergency and how to report electrical hazards. Plan electrical projects carefully and obtain all necessary permits before starting work. Ensure that the project is designed to meet all applicable codes and standards. Notify the utility company before performing any work that could affect the power grid. Follow the manufacturer's instructions for installing and using electrical equipment. Failure to follow instructions can result in damage to equipment, electrical hazards, and voiding of warranties. Use extension cords and power strips safely and responsibly. Do not overload them, and do not run them under rugs or furniture where they could be damaged or create a fire hazard. Replace damaged or worn electrical cords and cables immediately. Do not attempt to repair them, as this can create a safety hazard. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Do not attempt to perform work that you are not qualified to do. By following these guidelines, you can help to ensure the safety and reliability of electrical systems and prevent electrical hazards. Air conditioning and refrigeration systems are also a different, yet similarly important field. The consequences of operating without the proper licenses are similar. Remember safety first when dealing with any electrical, HVAC, or refrigeration-related work.